All right, here's a little part 2 to section 10.5. This time we're going to do a little theorem here. Let me flip back to the page. Again, let's stick a circle in here. And we're going to draw a radius to this circle. Let's make it a little bit bigger. And get my little marker. Let's do a radius. It could go anywhere. I'm just going to happen to put it straight up and down just to make it a little bit easier for us, okay? So there's a radius of the circle. Now I'm going to talk about a tangent. Now look where that radius is. The radius hits right on the circle. So guess where I'm going to draw a tangent? Yeah, at that point right there. Okay? Now, what does it look like just to your eye? It looks like it's perpendicular, doesn't it? Okay? Well, it is. You're right. Let's do this just for fun. Let's take this and, oopsie daisy, not do that. Let's take this. It's not working the way I want it to. Oh, I know what I want to do. Let's just do another color, and we'll do it in here. I just want to show you something. Let's do that green. Okay, watch this. What if I drew another radius, just some random radius in that circle, and then I did a tangent. Watch. Oops, I'm going to have to... Yeah, I'm going to have to play around with it a little bit, aren't I? Okay. So I'm going to have to go about like this. Take it up a little bit more. So I'm trying to get it so it hits just at the one point. You with me? And what does it look like with that? It looks like it's perpendicular as well. That's good enough, okay? So check it out. This is a radius, and this is a what? Tangent. Now the tangent's not just any old tangent. What does it do? It hits at the point of tangency. Do you see it? Hits the radius. Okay, when the radius is on the circle right there. So what do you think that makes? What do you think that radius and tangent do? Make a what? Make a right angle, okay? Look, same thing here. There's a tangent, there's a radius, see? And it makes a right angle right there. All right, that's theorem 10.10, all right? And we can do some examples with that. So let's do an example. All right, we draw this first example. This example is from example 2, page 719, if you want to look at it in the book. So they give you some, I didn't put in the lengths of the sides. They say that's 15, and they say this is 9. Let's see what is, and then this is 8. Oops. It's impossible. All right, JV baseball. Now the whole hypotenuse is not 9. Okay, now they put it right here, so it's from here. Where do you think? To right there. But guess what we know? We know that whole hypotenuse because we know the radius is 8. Do you see that? So the 9 is just from point to point. Okay? If they were to say that the whole thing is whatever length it was, they'd probably put like a bar like this and a line going like that. You understand that? So you know exactly what it was. Okay, but they don't do that here. So from this point to this point is 9, and obviously that's 8. So what is the whole thing? It's 17. Now, how do we know it's a hypotenuse? Because we know this is a radius, and they tell us that this is tangent. Okay, they tell it's tangent to this. Well, but the largest side is not always a hypotenuse. It always has to be opposite a right angle. So if that wasn't a right angle, that would not be a hypotenuse. Okay? It has to be a right angle for this thing to be a hypotenuse. Does that make sense? Not just because it's opposite the largest angle. Make sense, Daniel?
Will ever give you 8, like as a radius, and then you have to find the
Then ask for this. That wouldn't be enough information. Well, actually, yeah, you could. You could find it. Sure. You know what they're doing here? They're not actually asking you to find missing stuff. They're saying determine if this radius is actually, or actually if this is a tangent to the circle at this point right here. So with that information, they're saying, is this 15, is that line right there actually tangent to the circle? Okay? How would you figure that out? Well, you'd figure out, well, it would have to be a right angle then, wouldn't it? So right now, we actually don't know that it's a right angle. Does that make sense? So we don't know it's a right angle. What we're trying to do is show that it actually is a right angle. So how do we do that? We kind of do the converse of the Pythagorean theorem. Do you remember that? We did that back in whatever chapter it was. So how can we figure that out? Well, we take the longest side, you square it, and you compare it to the other two sides squared and add it up. So 15 squared plus 8 squared. I'm going to put a big question mark. Do you remember doing this? Because we figured out if the triangles were acute, obtuse, and right. That's basically what we're doing right now. We're just trying to figure out if this is a right angle or not. If it is a right angle, if we see, oh yeah, it is a right angle, then guess what's true about this line right here, this 15? It must be what to the circle? It must be tangent to the circle. That's what they're asking. You get it? So they're not asking you, they're not saying, okay, it's tangent, what is the hypotenuse, or what is this length, or whatever, okay? They're saying, here's all the stuff that we know, tell me if that's tangent or not. Well, if it's tangent, this thing must work right here, okay? So that comes out to 289, I believe, right? And this is, what, 225, and that's 64. Guess what that is? Is it 225? 9. Yeah, sure it is. What am I looking at? That's 289, absolutely. That's easy. All right, now watch. They're equal to each other. So if they're equal to each other, guess what this is? It must be a right triangle. It must be a right angle. So guess what's true about this thing right here? It must be tangent to the circle. Make sense? That's what they're asking it to do. Let's go to another one.